Yeah, thank you for having me. My name is Michael Ripperger. I work for Southwest Research Institute, and I'm the technical lead for the ROS-I Americas Consortium. So a little bit of background before we get started. Like I said, I work for Southwest Research Institute. Our organization leads the ROS-Industrial Consortium for the Americas. We're a not-for-profit independent research organization based in San Antonio in Texas. Actually function kind of similarly to A-STAR and ARTC. But we have 11 different technical divisions, sort of spanning the whole breadth of natural sciences and engineering, including robotics. And we kind of operate in the same sort of TRL level, 4 to 7 space for applied R&D. So in terms of robotics, SwRI has had a robotics group for about 35-ish years, sort of spanning a lot of different aspects of robotics. So we obviously use ROS and ROS-Industrial in developing advanced robotic software. We develop custom robotics as well as doing vehicle autonomy and autonomy for mobile manipulation and industrial use cases. So getting into sort of the updates from the Americas side. For those of you who don't know, we reached our 10-year milestone this year for the ROS-Industrial Consortium in Americas, so we're really excited to hit that milestone, and we thank all of you guys for being participants as well. So we've done a lot of really cool things. We got a video here that you guys can look at. That's kind of a montage of some of the interesting projects that we've done over the years. But again, excited that we've reached this milestone and looking forward to the next 10 years as well. So on the Americas side, we're continuing to foster collaboration within our membership. So we're hosting quite a few events. We had our annual meeting after the Automate trade show in Detroit back in June. So we had really good attendance there and got a lot of input for sort of future direction from our membership. But we continue to sort of do outreach through various different organizations, presenting at different conferences and trade shows, trying to sort of spread the gospel of ROS and ROS-Industrial to a lot of different types of organizations. So we also participated in ROSCON this year as well. ROS-Industrial had a booth that was in New Orleans about 6 weeks ago. So that was a really great show, great time to get everybody together and talk about ROS. We also presented a workshop about reachability analysis. And so we've got the link there for those of you who are interested to see what we were talking about. But ROSCON had quite a good attendance this year. Some of the main kind of focus topics that came up was a lot centric on mobile robotics and autonomy. A lot of talk about real-time applications and how to do development for sort of hard real-time requirements. And then a lot of different applications and companies talking about how they're using ROS and deploying ROS to fleets of robots and actually like selling products. So I think a lot of these talks are available now on the ROSCON website, so definitely check those out. I think there are a lot of good tidbits about how to improve sort of your performance with ROS and kind of take advantage of some of these new features that are being developed. So in terms of upcoming events, the ROS-I Americas Consortium also does training events. So if you guys have counterparts or are in the US, we offer these 3 or 4 times a year. So one I want to bring up here is that we do training for sort of ROS basics, as well as some other advanced capabilities, things mostly focusing on perception and path planning for mobile or for manipulators. So this training material is available to all the consortia. So if you guys are interested in some of these different types of topics, feel free to reach out and we can hook you up with the material or potentially do remote training sessions if that's of interest to you guys. We will also be having our annual meeting again next year. This time it's going to be at Southwest Research Campus in March of 2024. So if you guys are interested in coming, we'd love to have you. Cool, so kind of moving on to some of the technical updates here. I kind of wanted to review a little bit about our strategy in the Americas of what it is that we're doing and how do we get some of this ROS technology deployed out on the manufacturing floor, right? And so our role as sort of ROS-Industrial and the ROS-Industrial Consortium is kind of to be the interface between universities and this open source ecosystem and sort of end users who want to deploy this technology in their factories and creating products and things like that, right? And so we're kind of that interface piece, trying to take these different capabilities, really tie them into manufacturing and industrial use cases, and produce tools and libraries and examples of applications that show, hey, how do you take these tools and how do you take this capability and turn it into something that's really useful. And so as a part of that, we've kind of continued to engage with our manufacturing industrial contacts. And so there's a lot of different institutes, specifically in the United States, that are trying to pour funding into developing advanced capabilities for robotics. And so we've reached out to that network, and we're trying to sort of have ROS and ROS Industrial be a key component of those different manufacturing institutes. And then as a part of that too, we're developing projects and doing examples and actual deployments of these ROS-based systems, and having those also be publicly available, again, as examples and sort of working things that others can leverage to understand how to bring ROS into kind of the product and development that they're working on. So as a part of this whole strategy, right, the focused technical projects is a big way that we can actually bring people together to develop this type of technology. And so currently we have 2 ongoing FTP projects, but we're always open to supporting more, right? And so these focused technical projects typically are kind of a collaborative project amongst some number of different end users who are trying to develop a certain type of capability. So if you have any ideas for focused technical projects, feel free to reach out to any of your consortium managers. We'd be happy to try to connect you with others who might be interested in the same capability and try to get these focused technical projects off the ground. But I'm going to spend a little bit of time, whoops, see if I can go back here. Okay, so it looks like my video did not show up here. But I'm going to spend a little bit of time talking about one of the focused technical projects that we're running in our consortium right now. So that's the milestone 5 of our blending focused technical project. So this one is a fairly old project in the sense that we have been sort of developing this blending FTP since I think maybe 2016 or 2017. With the idea here being kind of, we would love to be able to put something in front of the robot, have it perceive that object, and then do sort of surface blending or grinding or sanding on that object. And so we've gone through a couple different iterations of this blending milestone of this blending FTP. But in milestone 5, we're really focused on a couple of key points here. Some of them being kind of a reconfigurable workflow where instead of having the robot be able to just kind of do the exact same thing right over, like perceive, work on, surface, repeat, we're kind of focused a little bit more on trying to make that workflow a little bit more reconfigurable, so we can sort of do the surface blending process, but then be able to incorporate QA and other types of tasks as well, sort of into that workflow without having to redo so much of the application. We're also sort of working on improved 3D segmentation, right? And so in our case here, for this focused technical project, we're working on steel castings and finishing steel castings. And so part of that is trying to instruct to the robot, hey, where do you need to go blend? Where do you need to go finish this particular part, right? And so we're trying to explore some different ways of interacting with sort of the perception and robotic system to be able to make that process a little bit easier. Again, and that kind of goes into the response to human cues as well, having some kind of limited input from humans to make that process a little bit easier in responding to that. And some of the bigger pieces here as well are these last 2 bullets: technology transfer and integration and testing. So as a part of this, one of our partners is Yaskawa Motoman, and so they're providing sort of a robot cell that we're going to be deploying at a foundry in Ohio in the U.S. And so part of this too is how do we package this system? How do we hand it off to an end user and sort of provide them with a level of support that they know how to use this, and that we can sort of efficiently transfer this capability to them. So so in terms of software improvements here, we've been doing quite a bit of work on our calibration tools. So in terms of calibrating 3D sensors to robots, trying to take some of those libraries that we have and clean them up and add some functionality to them. And additionally, sort of adding this capability here for detecting drawn boundaries. So I think these videos also are not playing here, but essentially what we've done is the top picture on the right shows this cast part that we're working on that we're trying to blend and finish. And so the workflow that we're sort of envisioning here is that an operator could go and mark these different areas, and then we could use a camera and perception system to be able to segment that out and sort of instruct to the robot, hey, this is where you need to go do your grinding or finishing operations. So we've also done quite a bit of work as well trying to enable stones for grinding. So in the past, we've used different types of media, more like kind of sandpaper type things. But for the casting industry, it's a little bit easier to use stones to finish these steel castings. And so we've done quite a bit of work on sort of the motion planning side and the process side to be able to enable stones for processing of these steel cast parts. Yeah, again, another video here that's unfortunately not playing, but our sort of target installation, not going to happen this month, but is slated to happen, I think, at the beginning of 2024. So we'll look forward to that. Again, all these contributions that we're making as a part of this focused technical project are open source, and they're being contributed on GitHub, and so we can share the links to those as well, with the idea that, again, this is kind of an example application of how do you take these disparate various tools in the ROS ecosystem and sort of marry that into an application. So I wanted to touch on a couple of other projects that we've been working on as well. So in this project and a lot of the work that we do, we leverage this Tesseract motion planning environment. So if you guys are familiar with Move It, this is something that's very similar, but a little bit more tuned to sort of industrial and process based, I guess, motion planning requirements. Anyway, so we've been working quite a bit to improve the various aspects of this. And so we've done a lot of work on the Tesseract planning side in terms of helping make process planning pipelines, being able to leverage different planners in combination with each other to get sort of a more efficient and more effective motion plan. We've also worked quite a bit on the ROS and ROS-II interfaces, and so now the ROS-II interface to Tesseract has reached parity with sort of the ROS-I interface, and we continue to do development on that and improving visualization capabilities and other things here as well. Some really good work here to check out if you're interested in Tesseract. In terms of robot drivers, there's been also quite a bit of development of porting robot drivers for various OEMs into ROS-II this past year. So this is something I just wanted to bring up and share with you guys to kind of raise awareness. So the Moto ROS-II driver from Yaskawa was released, I think, back in June. And so that's been a really exciting development because that's one of the only ROS-II controllers that actually functions as a DDS node on the hardware itself. And so it's kind of been something that people have been talking about for a really long time with the advent of DDS and ROS-II is, hey, the devices themselves can actually be the ROS nodes. And so this is a really great development from Yaskawa there. Also, UR, I think, is working on some ROS-II integration that's going to come out in Polyscope 6. I think that's something that maybe is slated to come out later this year or early next year. And again, there's been a little bit of work on ABB EGM drivers in ROS-II from Picnic. And then as a part of this blending FTP project I was talking about, we've also been sort of kicking the tires at trying to do a conversion of the Kawasaki KHI ROS control driver into ROS-II. And so I think that's something that we can kind of look forward to in the future as well. So along these same lines, you know, these robot drivers have been coming out, but they are not quite as hot swappable and plug and play as you might want them to be. And so we've kind of spun up this hardware interfaces working group to kind of discuss, you know, making standards around how these different robot drivers ought to function. That way we kind of have a standard behavior, and you could potentially switch from one vendor to another vendor and have pretty much the same type of capability. So the working group is fairly new. So if you guys are interested in collaborating and sharing some of your ideas about how these different robot interfaces ought to work, please reach out. We'd be happy to rope you into the discussions. So this project here is called SwRI. This is an internal research project that we've been working on at Southwest Research. But the idea here is that we have all these really great capabilities in the ROS ecosystem, but they're a little bit difficult to kind of stitch together into a single application. And it takes a little bit to kind of visualize how all these things, how all these different pieces kind of come together and work. And so the idea here is that with the SwRI project, that we can kind of take some of these motion planning and toolpath planning type of tools and embed them into a CAD environment to kind of give a little bit easier experience for users and be able to kind of enable better debugging of motion planning for manipulators and toolpath planning algorithms to really kind of understand how to build out an application and understand how to sort of build out a motion planning pipeline and do a bunch of debug. So this is a project that we're pretty excited about. We're currently working on a beta release. So if you guys are interested in kind of testing out this sort of capability, again, please let us know, and we would be happy to share this with you and get your feedback. A couple other projects that I wanted to note from the sort of the America side of our consortium. One of them is this optimized toolpath planning for tracking accuracy and velocity. So this project is an ARM Institute project. That's one of the manufacturing innovation institutes in the U.S. But the idea here is that traditional robot controllers kind of make a trade-off between path velocity and accuracy when you sort of just natively sort of program the robot to do something. And so this project is sort of investigating how can we better parameterize a robot trajectory to kind of maximize the velocity and path accuracy. And so they've got some really interesting results here about being able to take a tool path and sort of reparameterize it as sort of an optimal set of maybe move L's and move J's and move C's to really improve the velocity and accuracy of the path tracking. So this is a really interesting project that I hope to kind of leverage going forward. We've also gotten some renewed interest in additive manufacturing, and so we kind of spent a little bit of time revisiting the additive manufacturing stack for ROS and sort of integrating that with our motion planning pipelines as well. And so we wrote a little blog post here about some of our experiences, but this is something that we've got some renewed interest in and are working on making improvements for going forward. Again, we've also been working sort of in the space of assembly, and so we have this project with the U.S. National Institutes of Standards and Technology to kind of make a framework for testing assembly type of applications. And so this project is called Contact, with the idea here being this is kind of a framework that you can easily plug your robot into and then be able to kind of focus your development on the actual assembly task itself, trying to facilitate that whole framework to make it easier to develop these applications. So this is something that we've been actively working on and has been sort of beneficial for kind of developing and testing different assembly type of applications. So looking forward, we've got a few things that we're kind of focused on in this year and next year in terms of where we're putting our development efforts and some kind of high-level goals that we're hoping to achieve with some of the tools that we have in sort of the ROS ecosystem, the ROS industrial ecosystem. And so one of these is lowering the barrier to entry. So for a lot of our membership, right, they're manufacturing engineers who don't necessarily have a software or coding background. And so we're trying to focus now on sort of making better user interfaces and sort of making wrappers for our tools in Python just to make these types of tools easier and more accessible for end users who don't necessarily have that strong programming background. And again, sort of trying to expand to being compatible with Windows as well, just to open up this whole ecosystem as much as we can. And as part of that too, we're actively porting some of our tools from ROS-I to ROS-II. So we made quite a bit of progress, but there are still a handful of packages that need to be ported. And so as a part of this, we're kind of rethinking a little bit how do we do development, how do we structure some of these tools to make it easier to support ROS-I and ROS-II. And so we're kind of going through that deliberate design effort for a lot of tools and producing design documentation that's going out into the repositories for future. So if you look at it, you can kind of understand how it goes together and how it works. And some ongoing ports that we have from ROS-I to ROS-II is reachability analysis tool. That one is complete. We got some community contributions for the port as well, so we're really excited about that. We're also working on porting our calibration and toolpath planning stacks as well, and so those are ongoing, and we hope to finish those, I think, sometime early in this next year. This is a page for resources. You don't have to write this down. We'll share them on the slides, but just kind of wanted to put together a list of different websites for all the different resources, code-wise and consortium-wise, that we have here as well. But thank you for your time. I appreciate it.
You have a bullet point on continuing discussion with DDS. Mm-hmm. Are you able to tell us more, like what are you really thinking of, and DDS?
Sure. Are you talking about the bullet point on the ROS-Con slide?
Correct.
Yeah. So I attended ROS-Con. I just put that on there as a point that there were quite a few sort of presentations and discussions about how do you tune DDS for your specific applications. If you're having issues with DDS, What sort of things can you do to resolve that? So I don't think I have any personal sort of like feedback about that other than if you are sort of encountering DDS problems. There were quite a few talks at ROS-Con that are available in video form in the presentations. So if that's something that you guys are working on, those resources are out there, and there's probably some useful tips in those presentations about how to tune those DDS implementations. Yeah.
Thank you for your question. Does anyone have any other? Asha, may you please?
Hi, Michael. I'm Suyin from Automation SG. I just want to know a question is, what's the awareness of ROS in America, right? From the industry. That means, what's the take-up rate, how people are aware, how people are using it from a system integration perspective? Yeah.
Yeah, I don't know that I have any like hard numbers to share, but I think the growth is still fairly strong. I think in terms of, you know, when we're sort of hiring and looking at people, I think there are a lot more students now who are using ROS in the U.S. than there were maybe 5 or 10 years ago. And so I think that's a big development. And you see a lot of that at ROS-Con as well. Lots of students, lots of university labs who are using ROS and are not just sort of basic users, but are doing fairly advanced things. I think in the U.S. as well, I've seen quite a few startups that, you know, have built their solutions based on ROS and who are kind of at least participating in the ecosystem, if not necessarily giving back, at least being there and kind of sharing their experiences and stuff. And so I think there are quite a few companies on the Americas side that are definitely leveraging ROS. So I think the growth is positive. But yeah, I don't necessarily have any hard numbers to put to that. But yeah.
Thank you. All right. Is there any other questions? All right. If there are no questions, oh, sorry, one more.
Sorry, regarding the contact framework, what kind of interface do you use for to the robot? Is it a position interface, or do you use velocity or effort interface?
That is a good question that I don't actually know. So I'll have to look into that and let you know a little bit more. Yeah, but it's all based in ROS, so I think it's either position or join. Yeah.
All right. Is there any other questions? Thank you. All right. If there are no questions, let's put our hands again together for Michael. Sorry. Thank you.